Coming up on this episode of the IoT Inc. Business Show.
A big trend today is to bring the analytics to the data, not vice versa. And that is a bit of a shift where, you might export everything in the past to some other location for that analytics processing. Today, you do see more combined systems or hybrid systems because, if nothing else, we don't want to have to do all that data movement, never mind the duplication and redundancy that comes with it. So finding systems that are fluid that way as well is becoming increasingly important.
Column-based versus row-based, SQL versus NoSQL, and streaming versus batch. These are three of the most important dimensions to consider when choosing your IoT database. But let's get something clear. Databases are two levels of indirection beyond what's truly important, the IoT information you require. Databases support analytics, support information. Having said that, the informed business manager on databases will ask the right questions and set the right priorities during ideation of the IoT product. In this episode of the IoT Business Show, I speak with Nik Rouda, who breaks down the data environments used in IoT today.
All this and more on this episode of the IoT Inc. Business Show. The people, the business, and the technology of the next generation internet. This is the IoT Inc. Business Show. And now, here's your host, Bruce Sinclair.
Hello and welcome to the IoT Inc. Business Show. This show is made possible by sales of my book, IoT Inc., published by McGraw-Hill, and the IoT Inc. Certified IoT Professional, or ICIP, online training and certification program. Become a certified IoT professional by completing the program's 3 courses: ICIP Technology, ICIP Business, and ICIP Strategy and Digital Transformation. Details of which can be found at www.iot-inc.com. That's www.iot-inc.com.
With me today on episode 23 is Nik Rouda. Nik is an ESG senior analyst covering big data, analytics, business intelligence, databases, and data management, and has over 20 years of experience in finding IT business solutions. Nik, welcome to the show.
Hey, Bruce. Thanks for having me on today. Happy to join you.
So what have you been working on this week so far? What's your week been looking like?
This week has been mostly recover from 9 weeks of travel out at events and visiting clients and end users and trying to get some projects through and get some research off the ground.
Recovery week, I like that. Yeah, I know. We tried scheduling last week and it seemed like you were pretty much packed up.
Yeah, apologies for that. Life gets busy.
Yeah. So what shows did you attend?
So most recently I was at the Hadoop Summit in San Jose. It was a great one, looking at all the different vendors in play there, understanding the state of the market, the technology is coming out. Just a great opportunity to connect with everybody at once.
Now, when you're going to these conferences, and I know you do look at industries other than IoT, obviously, and specifically when you're looking at Hadoop, what percentage would you say, or how big is IoT now? I guess reality-wise and buzz-wise, what's the buzz when you're at these shows for IoT?
Well, it's one of the key words in the keynote drinking games for sure.
Right.
Everybody wants to reference IoT. It's seen as kind of the next generation of intelligence out there. So much more instrumentation coming that it's going to be generating so much more data that's going to need so much more analysis. So people are seeing it having possibly several orders of magnitude impact. People talk about this being a multi-trillion-dollar market opportunity altogether. So obviously everybody from a vendor perspective is all over trying to establish their relevance when it comes to Internet of Things.
Yeah. T's instead of B's, huh? So they're all over that action. Now, would you say that IoT is a subset of big data?
I would say they're compatible and tightly overlapping trends, but not necessarily one is a subset of the other. IoT has plenty of use cases that aren't necessarily oriented around big data analytics, and big data can be applied to many other things. But if you draw your little Venn diagram, there's a pretty good overlap in the middle that the one works for the other.
Yeah, yeah. So you would say then when working on data at rest, would that equate to big data?
Uh, Big data's got a lot of definitions. Usually it implies lots of volume. It implies a lot of variety. It implies wanting to have velocity and work with it quickly. But the IoT situation is interesting in that it will generate all this information that either can have an instantaneous response, or you may want to store and look at longer term patterns. And as a result, it does meet a lot of those definitional elements of what is big data. So I think as we get more and more sensors, more instrumentation of kind of every device and object around us, the potential to look at that and learn new things is really going to be tremendous.
Awesome, awesome. Well, I'm looking forward to getting into it. But when we start, tell me a little bit about yourself and specifically your background in IoT.
Okay. Well, I started actually long ago doing geophysics as an undergraduate, and a lot of that was around remote sensing. So we had devices that did gravimetry, electrical survey, seismic, all these different studies where we would lay out a bunch of sensors and then get massive amounts of data. In fact, that's what got me into the IT space in the first place, was working with a bunch of academics who knew the theory, but then when we were capturing this data, how do you work with it? Beyond that, I started doing Oracle classes 20 years ago. I've done a lot of technology and sales and marketing for various IT infrastructure companies, so the platforms that underlie this. I spent a few years with a startup in the UK that was doing smart homes technology, and we actually created our own sensors and our own hub and our own controls for a house.
Wow.
It was fabulous, but it was pre-smartphone, if you'll believe it. So you could control your house, but you had to actually text message it. And, text message it on phones where you had to hit the first key 3 times.
Yeah, I remember that.
So, it was perhaps a little too early, but it's definitely been an area of interest of mine from a couple of different angles: academic and consumer, and now as a use case for big data in my work as a analyst at Enterprise Strategy Group.
Yeah, it's funny how, most people can kind of look back and go, oh yeah, I have IoT experience, because, it covers such a wide spectrum. I'm the same thing. We didn't call it IoT, but we sold a platform to service providers so they could access the home network and then provide those types of services. But it's interesting. The geophysics is true, because that's all sensors and that's lots of data. And then how do you bring all that stuff together?
Absolutely. If we had called it IoT, then maybe we'd got a better multiple and valuation.
That's right.
But no, it's certainly applicable background. I found it useful, and it helps me connect a lot with people in this area. Just that I've had that range of experience.
Now, how long has ESG been focusing on IoT?
So traditionally, we were more of an infrastructure company. I would say starting about 3 or 4 years ago, coming up the stack, looking at data management generally. I was hired around 2 years ago to do big data and analytics as part of the space, and IoT was sort of inescapable portion of that. So as a company, we've been in this space only a couple of years, but it's a space that it's in some ways has changed so much in the last couple of years. I wouldn't say we've missed much. We've been learning it as everybody else has been figuring out the emerging technologies and trends. Yeah,
no, I would say a couple of years is kind of most of it anyway. So, well, listen, tell me something that we don't know about you. Tell me an interesting fact that most people are not aware of.
Well, in liking technology, sometimes I like to go old school. So I have a old 65 Mustang I've been slowly fixing, and a 76 pickup from Ford. And, they're definitely low tech pieces, but in some ways it's fun to be able to actually take things apart and fix them with your hands and not have to plug in anything to do so.
Yeah, I agree. I mean, I used to tear down engines, and my first real car, or my first sporty car, was a 1970 Cuda, and with that, it had a 383 big block. I took that out, right? I tore it down. I did the same thing. It was an automatic transmission, and you know what? It was pretty simple. There were very, very little electronics. I don't know, how people do it now. It's like, I don't necessarily have the inclination now, or more specifically the time, but how do you work on these things now? Now it's like changing chips, it seems, to give yourself horsepower, as opposed to me. I put on headers, bored out my cylinders, put on a bigger carb, big 4-barrel carb. I mean, it just seems like it's all electronics now.
Actually, that's a really good point, because to me, it is sort of reflective of this change towards IoT that, back then, a lot of things was just experience. A guy would listen to the exhaust note and say, okay, you're running a little rich, or look at the spark plugs. But to get access to those data points either took a lot of years of experience and intuition and just observation. Now you can plug in a little handheld device and connect her to your laptop and read out so much data about your exact fuel mixture and how the system's running and burning. And it's just transformative in terms of your ability to really understand live what's happening, even without those years of experience, if you have the right tool set. I mean, to me, that's kind of interesting. Another way this connects to cars is a great example everybody brings up about big data and smart sensors is insurance companies coming out like, if you plug this into your car and we can monitor your driving behavior, you can save a couple % on insurance. I look at that, I'm just horrified from a privacy perspective. I mean, telling a company exactly where I'm going, exactly when I start and stop. And I mean, it seems actually anti-consumer to me. Maybe you'll save a couple %, but hey, you have to stop suddenly because a deer jumps in front of you, and then your insurance company drops you because why are you doing sudden stops like that? It's just really kind of stunning to see. Some of the practical applications of IoT are phenomenal. Nobody can get against saying, hey, it'll save lives. Absolutely. But when it comes to personal behavior and especially trying to modify personal behavior and measure it, I have some serious privacy concerns.
Yeah. It's interesting because I think it's generational. My kids, they don't seem to even bat an eye, to these type of concerns. They're just teenagers, but it seems generational, and I never even considered that. I was just thinking, because now I drive. I used to drive like a maniac, and I don't think I should have had my license until I was like probably 21. But now the kids are telling me, I used to drive too fast. Now everyone's telling me I drive too slow, and I'm thinking, okay, well, if I drive too slow now, I'd love to get one of these things because I may as well get paid for my slow driving these days. It's not like I drive like a fast car, but it's funny that you look at it from a privacy perspective, and I never even considered. I guess I'm just looking at it from a dollar perspective.
Well, it's generational as well, in that once my kids start driving, I'm going to want to monitor their behavior. It's just
that's right. I don't care about your privacy. Yeah, and a friend of mine, he talking about just hooking up to the cars. I mean, he the CAN bus is the one, and I don't know if that is the port that's available to the consumer. I don't know if I think it's a different one, right, to the auto mechanic. But he plugs in, he gets an after the market gauge on his fuel to measure his fuel economy and all these. So he's got this whole set of gauges. He has a Miata, but he has a Corvette too. But he plugs it in, and he gets all this extra rich data. So some people are into it. But it's actually interesting that your hobby is very analogous to IoT. The transition that sort of happened in working in cars.
Yep, it's definitely interesting to watch it impact really all areas of life. I mean, to me, that's why IoT is so fascinating. You can look around you, and anything that can be plugged in, anything that has electricity, and maybe a lot of things that don't. I mean, there's a way to monitor that. And once you start collecting info on it, then you can start learning things about what it is, how it's used, how it's performing, and that's going to be really, really interesting.
Yeah, no, you're right. And then the other thing that you brought up was privacy, and it's funny because just in my inbox today, I received an email from Microsoft, and they're announcing that they're changing their privacy policies and how they're making it transparent. And, from a business perspective, we're going to get into it more in the show as we go on. But from a business perspective, it's unregulated at this point, but I think it could have a huge business impact. I was just reading an article just a couple weeks ago. So in my weekly newsletter, I choose 2, 3, 4 articles that I think are of value, and I put them in there. And one of them was on consumers lying. So they know that there's an exchange, right? I give you information, you give me some service or some product, but the advertising agency, I think it was an advertising research firm, was looking into it, and they were finding that, I can't remember what the percentage was, but it was less than 50%, but still pretty significant, that people were just lying. They weren't given the real information. So, there's a correlation there, right? With how you approach the data, how you approach how you're going to use the data, how transparent you are. Yeah, I mean, and it's interesting that was what, popped into your mind right away.
Yeah, it reminds me of the old websites. If you'd go visit like a brewery's website, for example, it would say, click here to verify that you're 21.
Right.
I wonder how many people that turned away that weren't 21.
Yeah. Right. Good point. All right, well, let's dig into the technology a little bit. I'm kind of eager to hear your thoughts on a few things. But what I'd like to start with is, as I start digging in, and this show started, we started from the sensor, and I'm talking, the analog, and then we went to the, to the hardware that's around the sensor. We started talking protocols, the software on the sensor, the networking, the cloud, and now we're getting closer and closer to where the real value is in IoT, and specifically from a business person's perspective. But something that's a little bit cloudy for me is really, if you could help by describing what's the relationship between analytics and the database. It seems like often they're used interchangeably.
Yeah, well, certainly one usually connects to the other, but to me, the database is the repository. So you have this information, you need a place to put it. Recording all that is the transactional aspect of the database. So once you have gathered that information, organized it either tightly or loosely, then you can take another view at that and try to understand it more. And sometimes you just want to do a simple readout of it. I mean, if your database is purely what transactions have we done, just list those for me. But analytics comes in when you start to ask increasingly complex questions, in my mind. So that repository can be analyzed in all different ways. You can start doing much more interesting queries. And to me, any good analytics exercise isn't asking one question and getting an answer. It's a series of iterative questions. Okay, wait, I got an answer. Now, but that triggers a couple other thoughts. What about this? What about that? If we look at it this way, it's the what ifs that kind of come in and make it really interesting. And the other thing I think that's kind of important in defining analytics versus databases. Database is not the only way to do the repository anyway. People think of a traditional relational database being well-defined, rows and columns and tables, table spaces, all those pieces. But there are other technologies that can be that repository that can be much more loosely defined. And Hadoop is one of those technologies that's coming out in the big data space as a general platform for data that once you've stored it and have that access, then you can look at it different ways, and you can have a database running on top of Hadoop. You can go directly at the data in different ways. You can build data warehouses or data marts as ways that are going to do deeper analytics against it and be more purpose built. But oftentimes, to take that raw data, there is some preparation that needs to be done before it's ready for analytics. You can do cleaning, you can do enhancement, you can do integration of different sources, all these different sort of ways of governing the data to help not just be a vast assemblage of facts that may or may not have any connection, but to actually start to establish some frameworks for how do you look at it and establish some standards for what will it tell you, and establish some really controls for quality that we do have good data, that people aren't lying here, that it's complete, and that the right people have access to it. So there are a lot of different aspects to it, but analytics to me is really just the ability to go ask those questions and see what comes back.
Yeah, no, that makes intuitive sense. Is I guess maybe it's the labels. When I hear Cassandra, when I hear Hortonworks, I guess really they're just based on a Hadoop database, but I almost think of them as both analytics, Splunk, Spark. Again, I think of those as analytics, but I also think of them as databases. But I suppose they're all running on Hadoop in that case, right? Is that, maybe just clarify that for me?
Okay, so some of those are Hadoop, some of those are more like a NoSQL database. But certainly you are facing the same challenge that everybody else does. That there's a lot of technologies out there. There's a lot of vendors out there. They have a lot of parallels, but they're not necessarily the same. And Hadoop, I mean, most people think of it at its core as being a file system that distributes across a lot of nodes, and then a MapReduce or Yarn type engine to go ask questions of that and perform the basic level sort of job activity management. When you get to other pieces like Cassandra, you may be closer to a NoSQL type database. But I think getting these definitions of what's Hadoop, what's SQL, what's NoSQL, what does it matter, what fits my environment? I mean, that's causing a tremendous amount of confusion in the market right now. And, people tie it back to business benefits and go, hey, this is going to make your business smarter. You're going to be more responsive, more agile, learn new things, get more ROI. They make all these promises, but getting into how each piece actually helps is often difficult for end users because you go from the top level claim down to some very, very specific technical features and kind of making the middle connections of how should I think about this. I mean, that's a big part of what we try to help people with every day.
Yeah, well, and that's what you and I are going to try to help people with today on this podcast. So we're going to look at 3 different forms of databases and then the analytics that runs on them. And again, for our listeners, like Nik says, a database is a repository of information. So that's really not the end game. And what's more important, obviously, is the analytics. And that's not important. What's important is the information that you're trying to figure out. And then from that, you can decide on what analytics best sorts out what you're trying to figure out. And then from that, the analytics will decide and maybe be tied to some specific database, right? So that's the chain of events. So let's go through the 3. The 3 I want to go through today are row-based versus column-based databases, SQL or SQL versus NoSQL databases, and streaming versus batch databases. So why don't we start, Nik, at the top, and can you compare and contrast row-based and column-based databases for us?
Okay, so the easiest way to think about this is really how is the database organized for most efficiency of whatever operation it's trying to perform. If you are, say, loading a bunch of records on a bunch of people, here's Bruce. I want to list Bruce, his first name, his last name, his job, his location, his social security number, his last purchase, all that types of things. So that's a row of information about you. And Bruce is the kind of the defining piece. And then everything else is describing some aspect of you that might be interesting later on. If I want to load that information, say you filled in a web form, doing that in a row and just saying, okay, I'm going to write all this sequentially makes perfect sense. And that's the most efficient way to do it. However, when you want to query something, rows aren't necessarily the easiest way. Say I have 10,000 different people in my database, and I want to know who lives in California. Do I need to go read every fact about every person in order just to see a count of how many people are in California? So when you get to specific fields that you want to do analytics against, so now we're not interested in everything about Bruce, we're interested in how many people live in California, then it's much easier to take a column approach and say, let's just read down the state of residence column and just do a simple counter and say, is it California? If so, add 1. If it isn't, leave it alone. And so that's much more efficient than when you're starting to read and ask questions and do analytics. So oftentimes people will load data into a row-based and then try to read and analyze data from column-based. And the same database can be organized both ways. People will build indexes on a row-based database to try and help it find this info faster. Problem is they kind of need to decide in advance what those search fields are likely to be. Or sometimes they'll take an existing database and they'll map it to a column structure and have both methods of access, one overlaying the other. And so there's a bit of blurriness. Now, you can't necessarily say one is exactly one or the other. More and more, even the large database vendors have tried to adapt to understand that their information is going to be used in different ways. And at the end of the day, like I said, it's all about efficiency. What's going to give you the fastest response for the activity you're trying to do.
So, if we're to pull this to IoT and efficiency, one dimension that I think you'd want to pivot on is time. And if you think about the sensors, even your geological sensors that we were talking about earlier, then in most likelihood, you're going to want to look at, it's time stamped, right? You're getting you're getting at this time, you're getting all this data, then time plus X, you're getting this data, then time plus X plus Y, you're getting this data. So does that imply then that a column-based approach would be most efficient for IoT, or should we be looking at, are there some other dimensions that we should be considering?
Well, time is definitely a factor in organizing to time series and being able to read things, being able to match and synchronize times across different components and devices. I mean, that's always been a challenge to make sure, say you're looking at server log files, what timestamp does every device have if you're having interaction between multiple servers, multiple databases, multiple users and applications? If those timestamps don't match up, then that can be a challenge. So that's definitely a key factor, but it's often time, just like Bruce, is an indicator of what we want to look at, and then there's another factor that says what was happening at that time and how does that correlate, link, engage other factors or aspects of the system as well. So another one that comes up all the time in geospatial is geospatial in IoT use cases. So knowing not when but where, and being able to pinpoint say inventory in a warehouse, or be able to find your trucks on the highway system, or track taxi cab paths in New York is a popular one because they've released all that data. So depending upon how you want to understand the information coming out of your things in your IoT environment, there could be different ways of orienting that and what you want to kind of key off as your primary dimension, and then relate everything back to that.
Yeah, no, that makes sense. And I'm just sort of, as you're speaking, I'm trying to think of different examples of column-based and row-based. And I don't know if, this is making a lot, more out of this than I should be, but I would think that most of the cases in IoT anyway. So this is a business manager listening to this show right now. They're thinking, oh, okay, Josh, okay, I need to decide. Is it going to be row-based, column-based, among these other descriptors? But when in IoT, are there cases in IoT when I do want to have a row-based example, or is it mostly kind of to do with column? Is it mostly a column-based experience?
Well, again, it can come down often to, are you doing transaction processing or analytics processing, or a mixture of both? So if most of your activity is going to say, hey, we need to be able to capture information in a set of organized fields as quickly as possible from, say, hundreds or thousands of sensors, loading things up in a row base may be the fastest way to do it. If you don't have that much data coming in at a given point, but you're going to be doing some really complex, heavyweight analytics against it, then making sure you're coming at it from a column orientation point of view can be faster. But like I said, more and more, a lot of the databases can be reorganized either on creation or on the fly around different factors for analytics, and there are different ways to do it much more fluidly than in the past. So I think row versus column may be a little bit of false comparison. The other thing I would say is, you triggered this thought saying this is predominantly business listeners, is really getting into the weeds of the efficiency of each of these operations is a very, very technical subject. So you're going to want to get a database administrator or an app developer to really drill down into how is my application performing, what are the activities I'm asking for it, what are the demands of those, and then what database format is going to do that. But it should all link back to the business case. What is the general workload you're trying to do stems back to what kind of business activities or questions are you trying to answer.
Yeah, no, absolutely. And, I call it the BIRD. I don't like the acronym, but it's the Business Information Requirement Document, that the business person is putting together. And I guess, again, for the listeners at a high level, I agree. This is not something we need to worry our pretty little heads over for sure. But if I'm making business decisions, or if I'm spending money on it, I want to at least have an idea at a high level what's going on. And I think what you're saying is, depending on this business information, depending on your business information requirements, you need to think what's the pivoting variable, or what's the pivoting dimension that's most important, and then that at a high level would probably tell you the way you're going to organize your data. But then again, of course, you're going to allow a database administrator or whomever is charged with this to make these decisions, or at least give you the options to make the decision. Yeah. Anything else to add to that?
I don't know if it helps make this easier, but a recognition that what you think you're trying to do with this data today is very likely to be different in a very short time. So
great, thanks a lot.
No, but it speaks to finding something that is going to, as a data platform, be really agile and help you be able to make changes as you go. Right now, hey, we don't know what we're going to do with this data, but we just want to capture everything from every truck driving out there on the roads. It's engine temperature, it's heat, all those, it's fuel efficiency, it's location, it's time, it's routes, all those different types of things. Later on, we might say, okay, now that I have this information, I've thought of a new application for servicing trucks or doing route optimization for deliveries. And so, what you think you're doing today, very likely to be different in the future. And so finding a platform that does have a broad set of capabilities and can be maybe simultaneously optimized for different types of activities is really where you want to go.
Yeah, good point. No, that's a good point. And just out of, for my curiosity, are you transposing the database and having to make a separate copy, or are you actually doing analytical gymnastics and on the fly kind of just efficiently looking at it from a different perspective, in the difference between the row and the column kind of base activities or analytics?
Yeah, again, great answer here is that it depends, but oftentimes, again, it's about what are the efficiency. Sometimes people can't do analytics against their system of record, that transactional database, because of the workload. They just can't afford to have all the CPU cycles and memory and stuff.
No, that's where I'm going with this.
Yeah, exactly. So people
that and also storage, right? So that's the two dimensions, right? You've got the horsepower and then you've got the storage. And so I'm just wondering, that's what we'll be paying for. So talk about it from that perspective.
Yeah, a lot of times people will do some extract, transform, load process to take out certain parts of that data that's been set up and move it to another database purely for analytics purposes. And this is where data warehouse came about, saying, hey,
it's still alive and well, right?
Oh, absolutely. I mean, companies are doing tremendous business in traditional data warehouses, particularly because they can provide the reliability and the performance and offload the other systems. And then they can set up little data marts for different work groups and make sure just the right information is available to different people. So oftentimes in the past and even in the present, there is an element of data movement here. I would say that a lot of people are trying to get away from that because, to your point, you may need twice the storage if I'm going to make a full second copy of everything for analytics. I may need twice the servers to process that. And just the cost in terms of dollars and in terms of time and in terms of effort to move data around is becoming really, really significant. And that's at current data volumes. When you get into IoT, this is going to just explode. And people are trying to figure out the economics of it. I think the technologies for IoT are in place. The economics we're still working out because people believe in the value, but the costs that come with it are uncertain. And so a big trend today is to bring the analytics to the data, not vice versa. And that is a bit of a shift where, you might export everything in the past to some other location for that analytics processing. Today, you do see more combined systems or hybrid systems because if nothing else, we don't want to have to do all that data movement, never mind the duplication and redundancy that comes with it. So finding systems that are fluid that way as well is becoming increasingly important.
No, and I think that you brought up a good point, and kind of that's the only way, at least I look at it from an IoT perspective, where I guess the primary way is bringing the analytics to the data, not the data, to the analytics. But I guess there could be a case for both situations. But I think what we're saying in terms of advice is, there's going to be cost for storage, there's going to be cost for computation, but maybe you have to, you're going to have to look at it on a case-by-case basis. Is that the best we can do here?
Yeah, probably. I mean, take an example, ATMs. Obviously, you're going to run around, you're going to perform a transaction, usually withdrawing money in my case, occasionally depositing checks. If there's a bank manager or somebody who's doing some analytics at, say, Bank of America, who I use, who says, hey, let me go find out about all the bank transactions happening out there. And he puts so much load on the system that it can't record the fact I took out $200. Well, actually,
that's an issue.
Actually, I'm okay with that if that doesn't get registered.
Yeah, that one you're okay with.
But if I deposit a check, et cetera. So sometimes these systems still do need to be kept separate because of uncertain workloads. And particularly if you get into analytics, you can ask some questions that put tremendous strain on systems if you're not smart about how you set them up. So there are still reasons why the two might be ring-fenced a little bit separately.
Yeah, no, that's a good point, actually. Using and analyzing the database and the performance considerations you have to take into account there. Yeah. All right. Well, let's move into the second one. SQL or SQL versus NoSQL or NoSQL. Why? Oh, before we do that, I wanted to, maybe you can just give us some examples. Is it worth it in terms of examples of a columnar-based databases versus row-based, or is there not enough to really go through?
There are. I actually will probably take a high road here and not name check particular vendors, but it's okay. Very easy to identify them. You can just jump into the Googles and type column-oriented database and row-oriented and see. But most of the traditional databases people are familiar with, the traditional relational ones, did start all as row-based and then build indexes on top of them.
Okay. All right. So let's move, talking to traditional, let's move to SQL and NoSQL, not so much traditional databases and analytics. Can you compare and contrast those?
Yeah, it's an interesting concept here because structured query language has been around for a very long time. It's been very tightly defined. It's proven and reliable. Some of the reasons people like it is it's what they call ACID compliance, meaning that depending upon how you perform things, they will be guaranteed in different qualities. And that's important that, you can apply the same transactions multiple times and get the same results, that you won't lose transactions if the system has an impact. All these different sort of factors. But the other thing that I think is the biggest boom here for SQL databases is that just it's built up over so much time that there's so much skill out there in the market. People know how to use them. They know that if they build an application to use SQL against a database, they can almost swap that database, and as long as the other one is also a SQL database, the same queries will return the same results. And people who build the same applications have a little bit more portability. They just also have more confidence and assurance in it because they've spent so many years around it. Now, downside of it is it's often its rigidity. And so SQL has had different iterations over the years as they've tried to add new operations you can perform. And some of the newer ones may not work on older environments or vice versa. So it's kind of required a little bit tighter definitions on things. And that's been great in historical use cases where data has been pretty tightly constrained and tightly defined. And you don't have a lot of variability there. But more recently, there have been some factors that are pushing people to try different approaches, and that's where NoSQL comes in. And I want to emphasize that NoSQL is usually my definition, not only SQL. Sometimes people refer to it as new SQL as well. But it often has some of the same queries and usually performs a lot of the same functions, whether or not they're worded the same. But people have turned towards NoSQL databases partly just because it isn't so strictly defined. I can load up all kinds of different data, some web data. I can load up JSON that might be more complex, where I might have some nested information or a hierarchy of information that a traditional relational database couldn't capture. The other thing that comes up quite often in NoSQL databases is having a distributed architecture, so splitting it up across a lot of commodity nodes.
It's easier?
Well, it's easier in the way they've implemented it, but more importantly, it can be more cost-effective. It can be more scalable. And in some ways, perhaps more resilient. The traditional way with the SQL database was to scale up. Let's get a bigger system. Let's add more memory, more storage, more CPU. With NoSQL in a distributed environment, often you're saying, hey, let's just plug in another server. Let's plug in another node. And that's very linear to scale, versus trying to get bigger and bigger giants and the heroics to support it. You just say, hey, I'm going to go get 1,000 little monkeys and let each one of them add just that much more workload. So in these new environments, so then where you have a lot more data coming from a lot more things and maybe not as well defined, being able to load video files, for example, or user information or all those different things. That's really important, and being able to support that is part of what's driven the need towards a NoSQL environment.
Yeah, and I think a lot of what you're talking about has to do with the inherent, I guess, topological structure of each of the databases, meaning the SQL databases have a inherent topological structure so that their processing is going to be efficient because of that structure, whereas the NoSQL databases don't have that hierarchical structure, at least is my understanding, and therefore to do certain relational type operations, perhaps it's not as efficient. Am I getting that?
Yeah, and so one way a lot of people think about this is that structure or definition of what the information is often referred to as a schema. And so you can create that when the database is made and say, these are the fields, this is the order they work, this is how they interrelate, and say that's defined on write. So as we capture the data, that's already set. With a NoSQL database, oftentimes you do what's called schema on read and saying, hey, I'm just capturing a bunch of information here. Throw it whatever you want in one big pile, and we'll sort it out later on.
Okay.
Now, there's a trade-off there. Is when you come to look at it later on, you got to sort through that big pile, and it may be more effort that way. It may be more difficult to code, more difficult to get a quality answer out of it if it's not well organized. But that's kind of the hidden price of that flexibility in there is being able to support more.
Yeah. No, and I was just going to say, I mean, what you were bringing up, let's bring it from a business perspective now, and you're kind of going there, but the 800-pound gorilla, that you're talking about versus all the different monkeys. I mean, these are these very large databases from companies like Oracle, for example, that cost a lot of money. But then what you're saying is, and I guess, maybe that's the question I want to ask you is open source versus proprietary. But then the downside is you may need a whole bunch of those linear servers you were talking about, a whole bunch of those little monkeys, to actually do the analytics that you require. So what's the balance here from a business perspective?
Yeah, you're absolutely right. There's a confidence element to this. A big vendor may charge me a lot more, but on the other hand, I know they can support me. They have the people. They've done this for hundreds, if not thousands, or more clients. There's an assurance that this stuff will work, be bulletproof. I'll be there. But the NoSQL space, open source, I may be relying on no one company to support me. I may be going to a forum and asking questions. Hey, has anybody else seen this? I may be downloading bits of source code from GitHub and saying, hey, let me look at how you programmed this, how you solved this problem. And is that applicable, or can I adapt it? Or I might be working with a company that's, just added Series A, Series B funding and saying, they've made a huge technological jump here, but do I trust that business will still be there 5 years from now when I've bet my my enterprise application against it? So there are those trade-offs with open source. I think maybe generational comes back in here again. That the younger kids of today like to just let me download it, let me play with it, let me try and build an app against it, see if I like it, see if it meets my criteria, versus doing a heavier weight trial. And the other side, the open source is a software versus proprietary versus community approach. There's also the hardware point of view, commodity versus purpose built. And a company like Oracle obviously is on the proprietary side for both software and hardware. They build the big appliances. They want to host it in their cloud. So, but plenty of others let you pick against those dimensions either way you like. And administering 1,000 little monkeys can be difficult. Just as administering one big box may be easier, if more expensive. So I think you kind of pick which approach feels culturally more like your organization, which fits your staff and expertise. Sometimes paying for that reliability and easier administration makes sense. Sometimes knowing you're going to make it up in just cheaper scale. Hey, if I get some smarter people working against this, or get a more self-managing NoSQL database, then maybe I'll make it back really quickly.
Yeah, and there's a whole other bunch of different ways to look at it too. Trying to get your minimum viable product, you may want to go, with a NoSQL approach. But the thing that we're not talking about here, and we've talked about it in a whole bunch of different episodes, is whether you're rolling your own or whether you're buying a platform. And analytics and databases are typically part of what they call IoT platforms, although that is a highly overloaded term. But if you're going to be actually building your own database and building your own analytics platform, I say on your own, then I think you need to take into consideration these points that we've just been talking about. But the other approach, obviously, or of course, is to go to a platform manufacturer, a platform provider, and they kind of take care of that, all those monkeys, so to speak. And although there is still that risk, I suppose, but when it's community based, someone can probably fix it. But is that maybe a difference with IoT than what you've seen in the traditional, big data, where IoT, there are these specific platforms that are built for IoT, and as a component of it, you have the analytics and, of course, the databases that support it?
Well, it's back to our working on cars from the beginning of the conversation here, Bruce. So some people want to have control over everything. You wanted to switch your headers and your cam and be able to decide exactly how that gets put together to meet exactly the performance you wanted. As my wife reminds me every time I do this, it only costs a little bit more to do it yourself. For most people, hey, I want a sports car, I want a big SUV. They're finding something that's already been built, that's already been optimized to a common use case. And so that's kind of the trade-off between build your own or buy a pre-built purpose thing. It kind of comes down to the group and how do they approach that. Oftentimes I see people doing NoSQL, trying to build their own IoT platform from a lot of component elements, and they may get something that is perfectly suited to their need and their application, and that may be something they're very happy with. But I think we get into trouble a little bit when the application guy, the database guy, maybe DevOps, goes too far without communicating back with the rest of IT infrastructure and operations. And that's where you show up in that purpose-built hot rod and they go, how am I going to support this? I have no idea what you've done. I have no idea where I get parts. I don't even know who to call on. So that's a real consideration. And I think platforms do have that aspect to them where, hey, maybe I don't even care what the database is inside it. It might be something they've built themselves, but as long as it works and they're going to support it, then I'm going to just go with that.
Yeah, no, and that's generally my advice. I mean, I think, unless you have a very, very specific use case that you cannot find a pre-built platform for, I don't recommend building your own platform. And the reason's simple. The reason is that's not where your intellectual property is going to be based. Again, looking at it from a business perspective, if you think about your company, where are you getting the value in your IoT? It's not the plumbing. It's not the database. It's not the analytics even. It's going to be the information that you're going to pull from there, going back to the BIRD, the business information requirement document. The value is in the information. So unless there's a real compelling reason for why you have to build your own hot rod, I hate to say it, I would recommend, myself anyway, I would recommend going the platform, approach. Am I missing anything there?
No, you're right. Bird is the word here.
Bird is the
word. Let's do what the business needs, not what's technically interesting, unless there's a good justification for doing so. And sometimes there is. I mean, a lot of this stuff is still new enough that, you may have a use case nobody's thought of yet, and that's very likely in the IoT space. People don't know what they're going to do with all this data or how they're going to manage it. So if you're inventing something new and that's where you get your competitive advantage or where you get your unique ability to meet that bird, then it can be worth it. And so I guess it really kind of comes down to taking an honest look in the mirror and saying, which fits me best, what's going to look best for my environment, my capabilities, my needs.
Yeah, and I think looking in the mirror and your capabilities is a good point. Just having an honest assessment of what your internal capabilities are. I work with customers or clients that are building IoT products, and they don't have, they just don't have that technical prowess. So it's really a non-starter anyway. But anyway, let's move on. The next one is, our next and last one is going to be contrasting batch versus streaming databases / analytics. Why don't you give it a go?
All right. So I used to mention, I used to work in marketing, and we wanted to have information about our efforts to find people to buy our product. And I remember working there, there was a certain information report that was given to us monthly. And so once a month, we got the information they thought was fit to see. And that's a great example of a batch. It may say, here's your budget so far. Here's what you've spent. Here's how many leads you've had. Here's what products you've sold in what areas. Now, that's great. But one, it's not very timely. I want to know what happened yesterday, not a month ago. 2, it's not necessarily very flexible. Just giving me that. What if I have other questions? Hey, I want to combine these in different ways. And 3, making changes to it was often onerous, to say the least. IT, would put me in their own work queue and say, hey, you want that new information? We'll get back to you in 3 months. By which point it's too late. I don't need that info anymore. And I may have even forgotten I requested it by the time they bring it back. So batch is often easy to operate. It's saying, hey, we're going to take data we have and we're going to look back historically at certain points and get that. And I don't mean to rail too much against it. I mean, my batch point maybe every 5 minutes. It could be, but usually it's not. Usually it's less frequent than that. But I could ask complex things with that as long as we've taken the time to set it up. Streaming comes in where people say, hey, I need to know right now. And this is real time. So taking it back to an IoT use case, let's take a power grid. Hey, I want to know if there's fluctuations in that power grid immediately and be able to respond to that. That's very different from saying I want to do monthly billing for each of my residences and businesses using my power grid. So there's a batch versus streaming in one environment that need to be able to behave differently. Now, I may want to also combine those and say, okay, hey, wait, we're having a huge demand on power. Let's go look through our historical data on utilization and see who could we cut back on without having impact. Okay, this is a hospital. Obviously, they have to have power. This is a residence. If the fridge is out for 2 hours, well, we better eat the hamburger, but otherwise we're okay. And so streaming is really, as it happens, the focus here is on speed and latency. It may also have restrictions on how ad hoc it can be, because you can't be live changing what you're asking if you're trying to do it instantly as well. But, aside from that, I think it gives you that in-the-moment response. And I want to clarify streaming at real time, meaning, semi-instantaneous versus people saying real time is as the business needs it. You hear lots of definitions there. Yeah. Well, real time for me is once a month because that's how often I'm going to add up commission statements or something,
Right.
But, having that auto response built in, being able to capture the data, do a quick analysis on it, store it again for later deeper analysis, or combine it with some stored information. All those are components of a streaming system that need to be done. I think the speed may limit the depth you can go to, or the amount of operations you can perform, because the more you do, the more time it takes.
Yeah. No, and I think, another way to look at it is data in motion versus data at rest, and also where the computation or where the analytics is happening. We've talked about if it's obviously in the cloud, it's going to be really hard to make this a streaming, kind of situation. Possible, depends. But more likely you're going to have to bring those, that analytics down a little bit closer to the ground and, to be able to do the computation. But it does bring up, a point or I guess a question is, I think working on data at rest is it's a different beast. It's a different animal than work, and you're trying to find different information, I should say. Again, speaking from a business perspective, than the real time. The real time, you may be doing it for efficiency purposes. You may be doing it to filter information. It may be part of your model where you have to react immediately. But it does bring up the point then, the structure of these analytics packages and their corresponding databases. Are you having to choose between one or the other? Walk us through that a little bit.
Yeah, people usually pick a database that will then handle that environment it needed. And one aspect we haven't talked about that comes up a lot here is in memory. So being able to do things in memory versus having to write it or read it from disk, way more efficient. It's already there.
Right.
You don't have to go through that seek and IO and all those pieces to actually get to it. So oftentimes the key factor for people around streaming is, can we perform everything we need to do in system memory, and then write it out to disk after we've answered our immediate need.
Interesting.
So you don't want to have in memory that cannot have a more permanent data store for a variety of reasons. You don't want to lose that data. You may need to have more capacity than you can afford for system memory, although its prices have come down and made it more economical. But for true streaming applications, usually in-memory is the way to go for your database. And in-memory options have been fitted onto some traditional SQL databases as well. Oracle, Microsoft, IBM, DB2 have all added in-memory over the last year or so. And it's interesting to take a native in-memory database, maybe somebody like a MemSQL, versus one of those more traditional players and compare how have they implemented it. Is it truly in memory? Is it truly going to meet my needs for my environment? And again, it's more of a technical conversation than a business conversation, but that capability to do things quickly often comes from where are you performing the operation.
Yeah, and the business perspective is obviously what's the information you're looking for, and therefore, does it need to be, done in real time? But I guess, it seems to me anyway that for most IoT applications, and that'll be you're building an IoT product or an environment or something along those lines or some variation, you're probably going to need both, right? And so that's what I'm wondering. You were mentioning that the SQL databases are starting to in memory like Oracle. Hadoop obviously has, I guess more real streaming examples like Spark and Splunk and SharkStorm. But are you having to then get are you then maintaining two different analytics packages, or are you able to maybe one database but two analytics packages? Is that kind of where we need to go if we do need to have both working on data at rest and data in motion?
It can be, and this kind of comes back down to, are these activities separate enough that I want to have a dedicated database or analytics platform for each, maybe dedicated hardware, or do I want to have them combined because my needs may change, that data may be used one way this instant and then used differently 5 minutes later, an hour later. So again, I'll go back to the idea of fluidity and your bird, knowing your requirements, figuring out which databases truly meet those most efficiently from a performance and from a cost and reliability perspective is what you have to do here. And in-memory approaches are newer because largely they've only recently become really economical. But even in memory, there's still those other dimensions of, am I scaling up my system to the gorilla, or am I scaling out and distributing it? All have implications in that architecture and how it's actually going to work in your real world.
Excellent advice. All right, Nik. Well, where can people find out more about you and ESG?
Well, they could go to our website. We are esg-global.com. Like I said, we're an independent advisory and analysis firm, so we don't have any stake in any one vendor. Mostly we look at this range of technologies and try and help people do, just as we've done today, a better understanding and better selection process of what they should be looking at, how to think about it, what really matters. So I'm always happy to have people reach out. You can follow me on Twitter if you want. I'm at NROUDA, so at Ruda, which is my initial last name. And otherwise, send calls and letters and emails and texts, and happy to jump in if I can.
Now, will you reply if someone actually mails you a physical letter?
I may look up their email address and reply that way, or pick up the phone, but that would be interesting. I can't say I've gotten a lot of physical mail lately, but let's go digital then.
All right. Well, like usual, we'll put all this information in the show analysis notes. And Nik, very informative. I appreciate it. And thanks. We'll talk to you soon.
Thank you, Bruce.
Okay. That was a fun talk with Nik Rouda. This podcast goes vertical, deep diving into different topics each week. If you prefer a more horizontal and structured approach to learning IoT business and its orbiting technologies, check out my book, IoT Inc., published by McGraw-Hill, or become a certified IoT professional by completing the ICIP training and certification program. For details, just go to www.iot-inc.com. Also go to www.iot-inc.com for an analysis of this episode, links to things that were mentioned during the episode, and very importantly, the episode's PDF transcript. Just search for the name of the episode or the guest. If you're new to this podcast, subscribe. That way you'll get every week's episode delivered straight to your device. Or, if you've been listening for a while, There are 3 ways you can support the show. You can leave a rating or a review on iTunes. Just go to iot-inc.com/iTunes. It only takes 1 click to leave a rating, a little bit longer to leave a review. You can share it on social. I'm on LinkedIn, to a lesser extent on Twitter. And of course, you can support the show by buying my book, IoT Inc., or the ICIP training and certification program. It's how I pay the bills. Next week's episode is IoT Analytics Best Practices in Process Manufacturing with Peter Zornio of Emerson Automation. I hope you can join me then. I'm your host, Bruce Sinclair. Thank you for listening. Until next week, may your path to IoT business be a tuned one.
You have been listening to the IoT Inc. Business Show.